Hello, AP Calculus. This is lesson 2 for 2.1. We're kind of going with the limits train a little bit further down the tracks. Today will be mostly about graphing and talking about limits from the left, limits from the right, and what to do when we're just, dealing with nothing but a visual and no algebra. So, I'm going to start with number 31. On each of these exercises, you're doing 6 different tasks. And you're basically looking at x equals 2 and x equals 0 as the points of interest. So, starting with x equals 2, on number 31, from the left, you're basically following the curve all the way until x equals 2. So this is what our y value should be from the left of x equals 2. Our y value should be 1, 2, 3 units. So for number 31, a, the limit as x approaches 2 from the left is 3. All right. From the right, you're following the curve all the way until you get to x equals 0. I'm sorry, x equals 2. When you do, your y value is only 1 unit off the x-axis. So x approaches 2 from the right is 1. Now the third part, the limit at 2. The limit as x approaches 2 of f of x exists only if the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the right of f of x. So you can only have a limit that exists and equals sort of like, you can only have an existence of a limit if the left limit equals the right limit. Since they don't, then you would have to say the limit does not exist. So limit does not exist. All right, let's talk about 0 now. So letter D, the limit as x approaches 0 from the left of this. So we're following the same curve, and we're stopping once we get to x equals 0. Now, it doesn't matter that they don't put a closed circle or an open bubble there. We can assume that every single one of these dots is sort of like a point that was highlighted just like these two. It's just, these were the only open ones. These would all represent closed ones. So, the y value at x equals 0 is 2. From the right of x equals 0, you're doing the exact same thing. Stopping at 0 still equals 2. So then the limit as x approaches 0, from the left it's 2, from the right it's 2. So at 0, it's 2. Let's try 33. Over here. Sorry guys, I just got the hiccups and I don't know if I want to stop this video right now. Whew. Mind over matter. Okay. So A, B, C. We're still talking about the same points as the first one, so approaching 2 from the left, 2 from the right, and at 2. So when you approach 2 from the left, you stop here. Now, it's what the curve, what its behavior approaches is what we're dealing with. So the fact that there's a point up here does not actually express the desired approach of this graph. This graph is converging towards a y value of 1 when you go to x equals 2. So that's exactly what you're going to put. As x approaches 2 from the left, your y value is 1. And then the same thing's going to happen from the right. From the right, you're approaching a y value of 1 unit. Now here's where things get a little tricky, because a lot of people want to say, that's what the dot is. The dot is where the limit as x approaches 2 of f of x equals. But that's actually not true. The limit exists if the left equals the right, and that limit value is what it converges towards. This is the limit as x approaches 2. So even though there's an open circle here, that y value is what the function is approaching both from the left and the right. So the limit as x approaches 2 is also 1 unit. I know, kind of tricky. Here's a question though. What does that point actually represent? Well, if you said, what's the function at x equals 2 units, you would say the function is different from the limit in this place. The function is actually, when I plug in x equals 2, I get 1, 2, 3, 4. So that's the difference here. It's just talking about something that has nothing to do with limits. Now, if we're talking x equals 0, from the left, you would go to 3. From the right, you're going to 3 again. So the limit as x approaches 0 is also 3. Let's try 35 now. All right, so we've got a very interesting function here. I guess these can be called step functions or greatest integer functions. We really didn't deal a lot of that. We really didn't deal at all with this in pre-calculus. But bottom line, same rules apply. So when we're talking about x equals 2, here's what's happening. From the left, we would have to say, this is the function that's representing the behavior from the left. Or at least that's the part of the function that's represented there. So, from the left, our function approaches 1 unit. So the limit as x approaches 2 from the left is equal to 1. From the right, well, from the right here, now you have to deal with, this is the step that we can use. It converges to y equals 0 units. And then since the left-hand side and the right-hand side of the limit do not match, then the limit does not exist. I have a feeling like if we did the same thing for 0, we're going to get similar results. So here's x equals 0. Zero from the left is going to be 1 unit. 0 from the right is going to be 0 units off the x-axis. And then this limit does not exist either. You know, feel free to put does not exist like this. Just make sure you know what you're doing and you're not just parroting sort of like some random acronym that I gave you. All right. Sorry, number 37, technical difficulties right now. There we go. All right, we got a very different function here. It seems to just appear out of nowhere at an open circle at x equals 0 and then moves to, well, it's going straight down. We have an asymptote at 2, and then it's going to go straight back up this way. So x approaches 2 from the left. As we go to 2 from the left, we just continue to go down, 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 basically an infinite, to an infinite negative basement. There is no basement. It just keeps going further and further and further down. So what we would do is we'd say the limit as x approaches 2 from the left of this asymptote would have a y value that approaches negative infinity. Similarly, from the right, it just keeps going up, 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 up. There's no ceiling. It just keeps going as far as it, basically there's no end to where it moves upward. That means that the limit is positive infinity when you keep moving up on the y-axis. And then the left doesn't match the right, so it doesn't exist. Now keep in mind, I'm going to throw this out here for you too. Let's say in an alternate universe that this were the curve and not this moving down here, all right? So pretend like this doesn't exist down here and it's moving up. The left would be positive infinity. The right limit would be positive infinity. But the limit still wouldn't exist because they're not converging to a specific they're not converging to a specific y value. There's no bridge. There's no bridging the gap at 2. They just keep going sort of in parallel universes, kind of side by side. They just keep moving north, and they never actually meet up. So this is a weird situation where it's like, hey, from the left it'd be positive infinity, from the right it would be positive infinity. Seems like those two would create positive infinity at that spot, but technically it doesn't exist. So I don't know. There might be an example like this later on. But I wanted to share that with you right away. D, E, and F, these are the ones that are checking out 0. So here's x equals 0. From the right, we know that it converges to the y value 0, and that would be the E value. But from the left, it doesn't even exist at all. So if there's nothing to choose from the left, you would have to say that the limit does not exist from the left of this, and you would also say the limit doesn't exist at that spot. So, the limit as x approaches 0 from the left doesn't exist. From the right it does. It converges to the y value 0 units, and then at that spot, if it doesn't exist from the left, then it can't exist at that spot. All right, I have time for one more of these graphs, so we'll just go to 39 as well. Yeah, this is kind of a similar situation, right? They're saying, hey, we'll give you one that doesn't exist from the left and have you work through that way. So x approaches 2 from the left. So here's x equals 2. From the left, it seems to be going to -1. From the right, it seems to be going to -1. And then, yeah, there's an open circle there, but it's converging to the value -1 at x equals 2. For D, E, and F, if it doesn't exist from the left, then you can't make any decision about what that limit is. And then from the right, it actually stops at x equals 1. I'm sorry, at y equals 1. But ultimately, if the left doesn't exist, then the limit doesn't exist at that particular point. All right, hopefully this video was helpful. I'm going to come back at you guys with some more from the same section.